All right, who am I? I am Nilsson from Corner Games and Corncrow Games. We are two studios up in north of Sweden, in Sundsvall. And so for the past 10 years or so, I've been working as a contractor a lot for big studios, EA and DICE, and finally back to the small studios that I love working with. So I was thinking, giving a talk today about maybe some of the lessons I've learned and sharing some of the things I'm doing right now that I think is useful for small developers as well as big ones. And it's about testing. So the topic is automated testing and how you make your gameplay itself, which is a bit of a catchy phrase, but that's pretty much what it is. So I want to clarify maybe what I mean when I say testing. There are ways of testing. You could say you test for feedback. You want to see what your players like, you don't like. There's also the QA testing, which is when you make sure the game is of enough quality, doesn't have the crash bugs, it just doesn't break. So typically, you have this kind of testing by the end of your project. You worked really hard, you're really close to finishing and you want to release, but then you have to do this quality assurance that everyone will insist on, your publisher or whatever, and this is a big deal. This is a lot of effort, and they can, if you have skilled testers, they will find ridiculous things that you never even thought of. And this is typically a very hectic period. And people say that, well, you need about as much testing time as development time when you make a game, which I think is true, but that seems very scary to have that much testing, but it can be really needed for big projects. But there's a different kind of testing too that you will do. Not everyone will do, but this is really useful, and that's during development. Because if you continually test, you avoid a lot of the things that you will bump into at the end. And also, which I think is important, that you will keep your productivity up by not breaking your game all the time. And when you make a game, you want to move fast, you want to break things, as they say. You want to add your features, you want new content, you want everything you can possibly squeeze in. The thing is, if you start breaking things, which will happen, it absolutely will happen, in a big team, you will kind of get this immediate feedback. If you're working with 200 people, you will, if you check something into the code so that a level doesn't load or like the menu won't show up, people will come and tell you immediately, like, hey, I can't work, I'm trying to run this level, but it's not starting. So you will have this very direct, and it will impact them as well. You can impact a lot of people badly. And on the other hand, in a small team like where I'm working right now, we're just a few people, and I'm the only programmer, you might not notice because everyone sits around doing their own thing. I do code my little things. I don't really play the game much. I'm just focused on my thing, and somehow I managed to break something small. And I'm not noticing it, but it has impacts on the whole game, so it doesn't run. And then you want to show the game, and you launch it, and boom, and something just breaks, and you didn't notice because pretty much you weren't really testing it. And I want to say also that testing sucks. I mean, that's what it is like. And this is from the viewpoint of a developer like me, working on my game. And when you start out and you have a small game, I would say you're making a puzzle game, Tetris, whatever. Anything in the beginning, the game is pretty simple. It's quick to start. You can test pretty much the whole thing you have just by launching it and playing for a few seconds. And as you come along in the development process, you add levels, you add features, you add quests, whatever you have, it will suddenly be the case that you can't test your whole game. you will most often test small things what you're working on, but you lose the whole you lose the ability to see the entire thing. And most of the time we want to just sit and add features. We don't like starting the game just to verify that, okay, it still runs, this thing runs, after we add a small feature that we think shouldn't do anything. We think, what could possibly go wrong with this code? It doesn't. It's just the inventory. It's just the sound system. It's whatever. And yeah, I think many have learned the lesson that there are many things that can go wrong. So, but we still want to. I mean, testing takes up a lot of time. You can't realistically spend that much testing. You have to find a balance. But we still want to move fast. We want to add things. We want to make changes that are capable of breaking the games. And by that I mean, if you're working in a game with a battle system, or you have whatever systems you have in the game, at one point, at many points, you will come to the situation where, well, to make this new feature, we have to rework all this code, or we have to change something fundamental about this. And we want to be able to do that. We want to have, to be productive, we want to be able to change things no matter what it is, and we don't want to be afraid that, well, now we're going to break everything. So, what can we do to sort of give us confidence that our game is in a good shape, and so that we can tell when things break? Well, the common way to do the first step, this kind of goes when you're starting out. If you're new team, you don't really typically have any of this, but as you grow, you will have a greater need of doing these things. And what I've listed here is the continuous integration. And if you're not familiar with that, it's the most basic thing is that you set up a machine that grabs your code, it builds it, it will report to you if, hey, this is okay, or something breaks here. So it's the opposite of sitting at your computer and if you have like Unity and sitting there and manually clicking build and producing the builds. You have a system that does this for you automatically when you push in new code or new data. And there are other benefits of doing this way, because it gives you this consistency in producing your builds. I have many times worked with when we haven't had this and we do all the builds manually. You get into a situation where it's hectic, you're preparing for some demo or whatever, and you have to iterate quick, and you want to produce builds over and over. And on your machine, you might have some special setting that you're using or whatever that's not meant to go into the game, but in the rush of things, that little setting that, maybe debug mode for the game or some God mode flag or something, whatever you put in there, will go into the build that you ship out, and that's not, that we want to avoid that. So having this automated is great, but that's just telling you if do we actually get a build out of this. It doesn't tell you, does the code do what it's meant to do. So the second thing here, which usually we will add, particularly if we're making game engines, is we have these unit tests where we automatically check functions, make sure that they return the right value. And I like to joke about this, because typically this is what ends up being tested with these unit tests. It's like math code, it's the engine code, but you don't very rarely test the game code. So do you use unit tests? How many here actually do you use unit tests? All right, that's good. How many do you test gameplay with it? Yeah, a little less maybe. But that is what I want to get to here. These unit tests, they catch obviously bad mistakes, but in my experience, they will check your code that's mostly stable, that doesn't change a lot, and which is, you iterate on other things in the game. You don't usually iterate on your math code. So that's kind of not enough. We want to have different answers. We don't want to know if math still work. We want to know the questions like if are these levels possible to finish, and not just individual levels. We would like to know: can I play the whole game? If I start it, is it possible to actually get to the game over when you completed the game? Can you do all the quests? Is there keys for all the doors that you can get into? And also, is there any hang? Is there any place in the logic where the game will lock up? That is what we want to know. And typically, we must play the game to know that. So sometimes you might say, yeah, maybe everyone should just test the game before you check in. If you didn't, well, that's your fault. You shouldn't have checked in that code. You should have tested level 9 to the end, made sure that, okay, but we don't do that. And that's what I was getting to with my testing sucks slide, that, yeah, it's too time-consuming and it's not really realistic. We can kind of make a judgment about what we want to test, and that's usually, it gets us close. We know what we should test with our code. If we change the menu code, we should test all the menus and so on, but things have unintended side effects. And to give you a bit of an example, something more concrete here, what I want to show you, I will just show what I'm working on right now. Just quick, and I will show you what I've been doing for testing this game a bit more thoroughly. This is I think the second time we ever show any of this game to anyone, but this is pretty much a game where you move around explore different locations, and you do quests, you find items, and you battle scary enemies. And this is the bug build, because you can tell from the extra text there. But I want to show you this so you get a sense about the things that follow here. So you move around here, you get into battles, which you find enemies. In this case, where the player is to the left and the enemy is to the right, and you have skills that you use. You battle, you hopefully kill them. You have items that you can use, throw grenades, and you can use bandages, etc. So testing this takes quite a lot of time. These battles can last for minutes, 5-10 minutes. And to give you an idea of playing through the first episode, it's 3 of these maps. It's about 2 hours to play this through. Sometimes I make changes to logic for the doors or for the quests, and sitting and playing 2 hours of gameplay gets a bit tedious. So with this game, this is a new game, fairly for me. So we're a small team. I'm the programmer. And so I wanted to make something different here with how we can test this, since we don't have that much time to spend for testing. We want to develop it. And my strategy, what I was thinking with this, is what I really want to do here is I want to get rid of, or I should not say get rid of the testing, but I want to automate as much as I can in terms of just checking that you can actually do the quests. You can go find the characters. You can win the battles. You can do the things that, if I go into data and change things, I want to quickly be able to know, okay, is this a valid thing? I moved the key from here to here. Is it actually playable this way? I could look at the map and tell, okay, yeah, sure. It should be possible, but I don't want to do the whole 2-hour thing of playing it through to the end. And also, another thing which I find very useful is having a way to check your game in an environment that's not graphical. We're making this game in Unity, and launching that even if it's quick to launch, I want something that can be run like on a server, or just something that I want to be able to look at a text version, which I will come to. I want to be able to run it without having all the graphics involved. So I wanted to have that able to test those things, but then what about the UI? Well, I decide, okay, in my experience, testing UI and testing visual output and sound, you cannot really, first of all, it's usually pretty easy to find bugs in this. You will see it on your screen quick. You can start the game and you will typically notice if something is wrong with this, and you don't need to play the whole game for that. So what I'm focusing here is the actual gameplay. So, but how can we do this? It's really challenging to automate tests for a game, because it's all one big blob, tends to be one big blob of code that interacts. The UI interacts with the gameplay, and it gets really complicated to just run things in isolation. And if we go back to think about the unit testing, well, people say, yeah, we can, unit testing, the engine code is easy because those are just libraries. The game is not a library, it's an application that everything just sticks together. So my thinking is, well, why can't we make the gameplay code a library too? Then we can actually do useful things like unit tests and more. So this is the kind of thing that I built here, and this there's a separation between the gameplay code, which handles the logic for your inventory, for your characters, the HP, and the attack. So all of that code are separated into what I meant. The label here is the simulation side, which is where all that goes on, and in the Unity side, I have all the rendering, the graphics, what you typically would have, but all the gameplay is extracted out of that and separated. And you will find that this is a way that actually many engines are starting to work like, where you have a separation, not necessarily just gameplay, but splitting the rendering, and some even run this independently, so you can run the simulation in a different frame rate. But that's a different type of thing. I want to isolate the gameplay. So, from my Unity side, I will use the game. I have simplified the code here a bit, but I just want to illustrate kind of what it looks like, and this is what it would be like from the Unity side. I have my functions to start a new game, I can load the game, I can interact with things, but the idea here is that I will do things, all the things that the UI does, like when I move an item to the inventory, when I use things from my inventory, all of that is, I have to call functions in my library. I can't go in and poke at the data. And actually, I in this case, I actually can, but I made this. This is rules I made for myself, and I haven't enforced them. But that's the idea. And you will find also that this is also similar a bit to when you make a networking game. You will have the server-side code and you have the client-side code that have to. The client can only tell the server, hey, I want to do this, I want to do that. It can't actually go in there and manipulate the state. So what this also means is that the Unity side needs to read, to know what to show on the screen, we have to read this state and act on it. So that leaves us with the two things. We can write unit tests, and there's the text mode. I call it the text mode version of the game. I always loved making text mode versions of my games, even if they're graphical. And this is kind of what it looks like. That's the game you saw screenshots from, and this is the text mode version of it. And you can tell that it's telling, so I'm printing out pretty much the events that come from the library. It's telling me, hey, show this screen, the prelude, show this text message, like welcome to the tutorial battle, that will end up on the screen. And it's showing me some battle stats, showing all those things that go on. So The next step, I will show you a live demo of this. The next step, of course, is, all right, I have my library, but I can do another step. I can do something that plays automatically. Okay, I don't have to click buttons anymore to manipulate my game or play it. It's all just a library. So I can write some code that actually does this for me in a kind of scripted way. So my next plan is, okay, I'll make this autoplay code that will take the game state. It will take some data that describes what to do. It will just look at the state, look at its script of what to do, and it will continually update it. So this gives me, here I'm just showing what this kind of autoplay script looks like for this game. No need to go into details, but it'll pretty much says, go to this zone, you do this action, like you search in this room, you go, if you can, you level up the characters. You have to do this actually in this game, and like equip the best items you have in the inventory. So this is what I would be doing if I'm playing. And as you saw in the game, in the screenshot, there are still random elements. You know, if the game didn't have battles, if it didn't have anything random, it would be completely deterministic. It could just go through all the game and test it for me. But we have random elements, like the fights. They are not the same, and you cannot script them. It would be impossible. It would take enormous amounts of scripting to figure that out. But then in this case, and maybe often, you have enemies that they aren't scripted, but they still play the game. They will fight you. So what I'm doing here is I have the AI code, and I will play the human side. My player side will use the same AI, but I'm boosting it a little bit. It gets a little bit more time to think. And that way, it fights itself for me. I don't have to sit there and think and click. The AI will play against itself. So, yeah, this is, I will skip this slide for now. So this is what it looks like when I do this. It's the same as before, and it will start the game, and now it knows what to do. It knows, okay, I get to a tutorial battle, I will fight the bad guys, and then I will go to some other location in the hallway. I will go into the library. I'll fight whatever enemies I encounter. And by the end, when it's finished, there's too much text to fit on this slide, so I just took the very last piece here. But what you see here is it lists all the battles that it played that we have. So I know here, just looking at the list, I can tell that, okay, in this battle, I took 195 damage in total. All my characters took this much damage from the enemies. The battle lasted for 32 turns, for instance. It lasted, you can tell them, and this gives me some idea of, are these battles balanced? Is there any battle which is like extraordinarily long? And I've seen this, and it's been very helpful to know that, okay, this is looking at all the battles, this one is really challenging. And maybe sometimes the script doesn't make it through. That happens too. And also I've added, since I know how many turns this take, I also can compute or estimate a playing time, like how long would it take to actually play this. So I get that as well. It's not extremely accurate, but it gives me an idea. Yes, it will lose. Yes, absolutely, it will lose sometimes. And yeah, I think I'll get back to that a bit really soon. So yeah, so it gives me statistics that typically I would try myself, but I know this now already. And I can tell the script will also, the game will tell me what places did it visit, and I can make sure that it actually went to all the places. That's real easy to code in this case. And this is, to me, this has been a great way to catch really strange things. And when I'm changing things in the battle system, and I have sometimes we have skills that will counter attacks from the enemy. The enemy will strike, I'll automatically strike back. Now, at some point we added a similar skill for the enemy, so he also strikes back. Of course, when these skills meet, he'll strike back, and you will end up in an infinite loop that crashes the game. I discovered this when I was running I made these skills and I ran my script, my test, and it crashed for me. So I had no idea what it was, but it was easy to see in the call stack. There was infinite recursion, and I knew that, okay, this is a problem. It would have taken me I think it would have been really challenging to find this. It would have taken hours and hours and hours of playing the game to find this. Also, it gives me confidence to see that the play, it makes it through the game. If it does, I know that it's possible to play. Sure, there might be bugs in the UI, but the actual gameplay logic is, it is possible to play the game. And I will get, as you mentioned, the AI. This will sometimes fail because the AI is not that great. Sometimes if it gets into situations where it's absolutely certain it will win or absolutely certain it will lose, it will have a hard time knowing what to do because it looks at the options and it knows that, okay, all options give the same outcome, like I win. So it doesn't matter what I do, I'll just do nothing. And that happens. And I have some features that I can toggle here in these playthroughs, like God mode or quick AI, where the enemies spend very little time thinking, or I can skip the battles entirely and just give me the testing of the other things, so I can verify like keys. I can get to all the locations, etc. It'll just automatically win the battles. It'll get to a battle and automatically win because it's cheating. So I'm running a bit low of time, but I will give you a demonstration. And so I did all of this, and then I thought a bit more about this and figured, yeah, I'm running this text mode game version, but what about, I still have to play, I run the game in Unity, I still have to play it. I have to click, I want to see what the battles look like, whatever, I still have to click a lot and sit around and wait. So I figured, hey, I could take this autoplaying code that I wrote. It's just a class that handles everything. And why not just put it in the Unity code and have it do the things for me? Since it's separated from the UI, the game logic is separated from the UI, I can do this. And hopefully I was thinking, yeah, maybe the UI should still pick up the states that happen in the gameplay. Like if I go to a location, it still has to look at this state and know what to do. So now is the time for me to show what this means. And I won't be, Jesus, did it crash? Whoops. No. Are we screwed? I wanted to show this. Yeah, we can do this. We can do this. We can do this. Okay, so I have made for myself. I made a special mode where I start when I click the new game. If I hold Shift, it will start the autoplay mode, so I don't have to do it, which I will do right now. Okay, the autoplay code is running. It knows that if there's a dialogue, it has to skip the text option. So I sit back and watch where it closes the pop-ups. Okay, that's the enemy. Now it's the AI playing here. And at any point in this, I can press escape and break this. It will break the autoplay code, and I can continue playing from where it left off. So what I've been finding myself doing with this is I'm starting it on my laptop or a different computer, and just now it's finding loot. It's going to the places where it can find a lot of loot. As you can tell, I have some buttons for my own testing, which is the cheat win button, and the toggle auto, which will toggle the automatic playing. But it's a way for me to not have to play it, and I can just look at the game and see, okay, what's going on here, and I can see how the AI uses the skills, which gives me an idea of, okay, is this skill overpowered? Because the AI will figure that out and use it a lot. And also I can check the animations, the sound, without actually playing it, which I still play it myself, of course, but this is just a great way to not have to do it that much and still be able to verify the game that is running. All right. Yeah, that's it. Thank you very much.
Yeah, thank you for the presentation. Since the hall is ours pretty much until 1 o'clock, then if anybody wants to get a quick question in, yeah.
Very cool that you separated the game to the pure data text part and graphics part, but actually it is not required for automated testing. Like no. I did some automated testing for some games, and I usually did it through UI. Basically, I had the same AI playing the game, the same as you just showed, through the graphics interface, and that works absolutely fine.
Yes.
So separation is actually not required.
No, it's not. But I wanted to show that because it's something I find useful for games where you have a lot of like the RPG games where you have a lot of stats, you have a lot of numbers. In a text mode game, you can output all that data, and you can view the internals in the text mode, which is difficult to do, in the graphical mode. So for me, that's the way I like to do it. But you're right, you don't need that.
Have you tried to test through graphics interface, UI test?
Yeah, I have made some few attempts, but I didn't like it. It gets too messy for me.
Okay, so you're like text guy.
Yeah, very much so.
Okay, cool. Thank you. Very impressive.
Thank you.
Okay, then I would say this is a wrap. So thank you. Very awesome presentation.
Glad you liked it.